Some concepts of regression? What are degrees of freedom? Degrees of freedom, DF, is a statistical concept that refers to the number of independent values that can vary in a statistical analysis. In other words, it is the number of observations in a dataset that can vary without affecting the number of parameters estimated in a statistical model. In simple terms, degrees of freedom represent the amount of information available to estimate a statistical parameter or calculate a statistical test. For example, in an AT test, degrees of freedom are calculated based on the number of observations and the number of groups being compared. The larger the degrees of freedom, the more precise the statistical estimate or test will be. Degrees of freedom play a crucial role in many statistical analyses, including hypothesis testing, regression analysis, and analysis of variance, ANOVA. They are typically denoted by the symbol DF, and can be calculated using various formulas depending on the statistical test or model being used. What is SSR? SST and SSE in linear regression? In linear regression, SSR, SST, and SSE are three important terms that are used to measure the goodness of fit of a regression model. SSR, sum of squares regression, is a measure of the variation in the response variable, y, that is explained by the regression model. It is calculated by summing the squared differences between the predicted values, y hat, and the mean of the response variable, y bar. SSR measures how well the regression model fits the data. SST, sum of squares total, is a measure of the total variation in the response variable, y. It is calculated by summing the squared differences between each observation of the response variable, y, and the mean of the response variable, y bar. SST measures the total variation in the data. SSE, sum of squares error, is a measure of the variation in the response variable, y, that is not explained by the regression model. It is calculated by summing the squared differences between the observed values of the response variable, y, and the predicted values, y hat, from the regression model. SSE measures how much error there is in the regression model. In linear regression, the goal is to minimize SSE, which means finding the best fitting line that explains as much variation in the response variable, y, as possible. SST can be decomposed into SSR and SSE, such that SST equals SSR plus SSE. The coefficient of determination, r squared, is then calculated as SSR, SST, which measures the proportion of the total variation in the response variable that is explained by the regression model. How to measure the maximum likelihood estimation for normally distributed data? Maximum likelihood estimation, MLE, is a commonly used method for estimating the parameters of a probability distribution based on a set of observed data. For normally distributed data, the maximum likelihood estimate of the mean, micro, and standard deviation, sigma, can be calculated as follows. 1. Likelihood function. The likelihood function is a function of the unknown parameters, micro and sigma, that describes the probability of observing the data given these parameters. 1. For normally distributed data, the likelihood function is given by L, micro, sigma, x, equals 1, square root, 2p squared, asterisk express, x micro, squared, 2 sigma squared, where x is the observed data. 1. Log likelihood function. To simplify calculations, the log likelihood function is often used instead of the likelihood function. 1. The log likelihood function is given by lane L, micro, sigma, x, equals north 2 lane, 2 pi, north 2 lane, sigma squared, n area summation, x micro, squared, 2 sigma squared, where n is the sample size. 1. Maximum likelihood estimation. The maximum likelihood estimate of the mean, micro, and standard deviation, sigma, can be obtained by maximizing the log likelihood function with respect to these parameters. 1. This can be done using calculus and numerical optimization techniques. 1. Specifically, the maximum likelihood estimates can be found by setting the partial derivatives of the log likelihood function with respect to micro and sigma to 0. Partial differential, lane L, micro equals n area summation, x micro, sigma squared equals 0 partial differential, lane L, Partial differential sigma equals n, sigma plus n Airy summation, x micro, squared, sigma cubed equals 0. Solving these equations simultaneously yields the maximum likelihood estimates for the mean and standard deviation. It is worth noting that there are also built-in functions in many statistical software packages, such as R, Python, and MATLAB, that can calculate the maximum likelihood estimates for normally distributed